We have been talking about exponents, but the topic of square roots is basically like the exact opposite of an exponent. So we need to make sure that you're really confident on that as well. So let's just do a basic. I don't know what you remember, what you don't remember, but hopefully today is not too bad. Okay. So first off, we're just going to start with, this is in our journal section, our main ideas. This square root right here that I've written is empty, but we never put a 2 there, but by default we know that it means the square root, which means a number times a number. A number multiplied twice. 5 times 5, 6 times 6, 3 times 3, 10 times 10. So basically what I would ask you is I would say, what is the square root? And then I'd give you some number like 81. And it means what number times itself? 2 times is multiplied. Square root 2 times is multiplied to give you 81. And then you would write equals what? 9. Okay? So in a similar broken down form, the square root of 25 equals 5 twice. And then obviously 5 times 5, square root 25 is just a 1 5. So sometimes students, when they write their answers, they still keep the square root over the 5. I've seen this a lot. I've seen students do this as their answer in blue. And that's totally wrong. Because the reason that I take it out of the square root sign is because it was a number that was multiplied twice. So you do not want to keep your answer in a square root. Then the next thing that I have there is the cubed root. Cubed root is a little 3. That means something times something times something. 3 times. And we get those numbers like 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. So there's my sample. The cubed root, or the third root, of 27. The cubed root of 27 means 3 multiplied 3 times. 3 times 3 times 3. And your answer is just a 3, not square root 3, just a 3. You can also break down square roots into perfect squares. Perfect squares are, ready? 4, 9, 16. Do these numbers seem, do you understand why? 4 is a perfect square, 9 is a perfect square, 16, 25, 36, 49, 64, 81, 100. Those are called perfect squares because they perfectly break down because 2 numbers multiply to make them. So 8, look what I did with 8. I broke down 8. It is not the third power, so I could not write a 2 there for 8. It's the second power. So you have to ask yourself, are there any perfect squares in 8?
No.
Well, there is. 4 times 2.
Oh.
So this 4 times 2 gets written out instead of 8. Now, what number is the perfect square? Is it the 4 or is it the 2? No. What's the number that,
4.
like from my list that I just listed off? 4. So what happens is the square root of 4 is a perfect square, so it's going to come out. What does the square root of 4 come out as? 2. So the 4 came out. It came out as a 2. What's still underneath the square root sign?
2.
There's still a square root of 2. So this is really what we're practicing today, breaking down. I'm going to say break it down because that's how I say it. So we're going to break it down. And if you know that there's a perfect square in that number, you have to break it down and pull that number out. 2 rad 2. 2 rad 2. That's how you say it, radical. 2 radical 2, or 2 square root 2. That's how you would verbally say these things.
You're like my mom.
Great. I'm sure she's an awesome woman. I hope so. All right. Can you guys go to the examples and fill this chart out, please? Over on your left side. Just do it on your own. This will really help you for the quiz. FYI, FYI. Write the answers. Okay. Square root of 1 equals? Square root of 4 equals? Square root of 9. Square root of 16. Square root of 25. Square root of 36. Whoa, pattern. Square root of 49. Square root of 64. 81. Square root. 100 square root. Square root of 121. Square root of 144. Okay. Are those committed to memory by now? Yeah? Good. That means you're going to get 100% on the quiz.
Oh, sick.
Yeah. So now, let's do some together. Some of these are easy and perfect squares. Number 1 is a perfect square. The rest of them, we got to work at it a little bit. Okay. What is the square root of 25?
5.
So put a 5 there. What is the square root of 4?
2.
So I am actually now multiplying 5 times 2. Not the square root of 5, just 5. It pulls out as just the 5. Because 5 times 5 is 25. 5 times 2 equals 10. Your answer, number 1, is 10. Number 2. Only the 9 is under the square root, my friends. What is the square root of 9?
3.
What is 3
15.
times 5? So your answer to number 2 is 15. Go bit by bit. Don't rush anything. Number 3. 20 is not a perfect square. Is there a perfect square inside of it? Think I got 2 times 10. No. 5 times 4. Ooh. Okay. Here's how I want you to do this, please. Follow my directions. Don't work ahead. I want the 4 to come first because that's the perfect square. 4 times 5. Okay, the perfect square gets square rooted out. What is the square root of 4? Take it out.
2.
So draw your little line, take the 2 out. The 4 is no longer inside the square root symbol. But what is still there? So I have to write 2 rad 5. 2 square root 5. 2 radical 5 is the answer. 2 times radical 5. If I got a calculator and I entered radical 5, it'd be something like 2.2. And then I multiplied it by this 2. I would get the same answer as if I put radical 20. We don't use calculators for radicals yet. You definitely will, though, in the future. Okay, number 4. What is, 24. Is that a perfect square? But is there a number inside of it that is?
Yes. 4.
4 times what?
6.
4 times 6. Put the 4 first. Take out the perfect square. Out. Square root of 4 becomes what? A 2. So that's taken out of my square root. 6 is still there. Keep the 6 in the square root still. Any questions so far or confusion? Because this is super easy today, it gets harder and harder and harder. Yep.
You also use 8 times 3.
You could use 8 times 3, but 8 is not a perfect square and 3 is not a perfect square. So 8 times 3 would not be a good choice. It wouldn't be the fastest choice. Yes?
In on a test or on a quiz that we take on this subject, is it okay if we can just write 2 rad 6?
And jump to that answer without showing your work?
Well, no, but just instead of 2, the square root and 6 and leaving it.
You want to write the word RAD?
Yeah.
No. Sorry. No one does that in math. You don't write out the word, you use the symbol. Symbols are shorter, they're quicker, and they're understood universally. Okay. Number 5. Something third root, something 3 times makes 8. What number 3 times makes 8?
2.
So you're just going to put 2. Not square root of 2, just 2. All right. 6. Something 3 times makes 64. Something times something times something? 4. So good. Do that. It just equals plain old 4. Okay, let's move on. Now, my question says 2 rad 8. 2 is already out there. Leave the 2 out there. We're just going to kind of table it on the side for a little bit. Just let it hang out there. But the rad 8 we need to deal with. Because 8. Is there a perfect square inside of 8? What is it? So I'm going to write this. 2, keep the 2 there, just like leave it over there in storage, because we're gonna need it later. 4 times 2. What can I take out? What's perfect square? 4. 4 comes out as a what? Okay. See how there was already that 2 there? From initially?
Yeah.
They now get multiplied. Not added or subtracted or divided. It's a multiplication. What's still left under the square root sign? Keep it there. So now, you need a final answer. You need to multiply the blue and the red. What is the blue times red? 4 radical 2. That's your final answer. We need to go down the smallest possible number that we can inside a square root always. You break it down, smallest you can go. You would be wrong if you left your answer 2 rad 8 on a quiz or a test. Because 8 can be broken down. And you need to know 4, 9, 16, 25, 36 in your brain as numbers that you can pull from and pick from. Okay, number 8. I need a number that 4 times makes 16. 2 times 2 times 2 times 2. Remember that worksheet that I gave you earlier in the week and it said common and there were all these like square roots there and powers and stuff? Those common exponents you'll see a lot. And that's like here today. 2 to the 4th power was written on that worksheet as a common one that you will use and see. Okay? Number 9. There's a 3 out there. Just keep it out there. Put it in storage for now. We don't need it yet. But we need to talk about the 4th root of 81. So this 3 is just going to hang out over on the side. What times what makes 81? 3. So this whole square root, 4th root of 81 becomes a 3. Let's connect it with that number from storage, and I'm going to have a 3 times a 3. 3 times 3 is 9, and that is my answer to number 9. Okay. Number 10 is jumping up a level of difficulty. You ready for it? The first thing I want you to notice about number 10, I know, zoom in, is that these 2 3s match up and they're going to end up canceling each other.
So there should be 3 times.
And this one has 4. But right underneath a 4 is a 3, and a 2 and a 1. There's a 3 inside of a 4, right? 3 plus 1, 3. It's right. So here's what you're going to do. This one takes a couple of steps. Let me go slow. Boop, back. Okay, the 3 to the 3rd. The 3rd root of 3 to the 3rd. What's that? What's going to happen? Any thoughts? What do I, okay, so what am I going to take out then?
The 3.
The big 3. Because these little 3s were kind of like the same. Now, here's my issue with the 4. I'm going to break down the 4 and I'm going to write this. I'm going to write 4 to the 3rd times 4 to the 1st. And the reason that I'm doing that is because I need to think of something that's going to cancel out the cubed root, the 3rd root. And a 4, the way it is, nothing can pull out. But if I break it up into a 3 and a 1, then I can take out the 4 to the third. Do you see how the 4 to the third is going to be taken out because there's a cubed on the outside? They're both 3s. Because those numbers match up, and it's a third power and it's a cubed root, they're going to essentially cancel each other out. And this 4 is going to come out. So now, this is what I have. Mathematically, I'll do it all perfect. The 3 from the outside that I pulled out. Cubed root of 4 to the third times 4 to the first. I broke down my 4 to the fourth. Why didn't I pick 4 squared times 4 squared? Anyone? Because that makes 4. 2 plus 2 makes 4. Why didn't I do 4 squared plus 4 squared?
Because then the third power would be 4 thirds.
Because then the third power wouldn't cancel. 4 squared doesn't do anything for me. So now I've got this third power here and this third power there, which means my 4 will also come out from that. I chose to break down my 4 to the fourth into something that I knew would be able to be taken out. It's the cubed root. We call that cubed root, the third root. So think of something that has a power of 3. All right, so this now is what I have. The 3 from my 3 to the third, that one came out. The 4, now that I just took out, right? What's still inside?
4.
A 4 to the first. Please don't forget to put cubed root, because if you forget that little 3 in there, it's going to mean square root, and then you get the problem wrong. Cubed root is different than square root. Can I cube root 4? What times what times what makes 4? Nothing. So you have to stop. What's my last step for simplifying fully? 3 times 4. Yeah. 12. The cubed root of 4. 12 times the cubed root of 4. Okay, number 11. Third root of 8, third root of 8. 8 times 8. What can I make those 8s become? How do I break it down, those 8s? I don't want to make it 64. Nope. There's another way. What is 8? No, because remember we're dealing with a little 3 out there, cubed root. I'm not dealing with square root. I don't care about 4 today. 2 to the third power. So smart, he made my 8s become 2 to the third powers. Why did he choose to say the third power part?
Because 2 times 2 times 2.
2 times 2. And look at these 3s all in common that are going to be able to take out. It is the same answer. I didn't feel like dealing with larger numbers like 64, so I just decided to. What's 2 times 2? Cubed root of 64, you're right. Okay, what about number 12? What's the square root of 3 squared? What happens with those 2's? The square root of 3 squared. So what comes out? I'm not going to make it 9, and I'm not going to make it 16. Then I'm going backwards. I'm dealing with these huge numbers that I don't need to. Look at how the squared would cancel out. A 3 comes out. What's the square root of 4 squared?
64.
Don't say, no, it's not 16. The square root of 4 squared.
2.
No, someone said it. But now people are saying the wrong answer, so now I have to address this. What is the square root of 4 squared? 4. Because the 2's cancel. But I don't write my little 2 ever. I'm never going to put this 2 here in this little crease. It is implied that when it is blank,
It's just a 2. 2.
It's a square, 2. The answer to number 12 is 3 times 4. They both come out. The 3 comes out and the 4 comes out. My answer to number 12 is 12. There are a lot of little details to this. Okay? All right. So this is my homework, my classwork / homework assignment. But you have to take the quiz, so we're kind of not going to do very many of these. The things that I think will be the most difficult for you. Can everybody look at 24? Can you think of a number that's the 4th root of 81?
Yeah.
What?
3.
You guys are so smart.
What is -6 times -6 times -6, though? -6 times -6 is positive 36. Positive 36 times -6.
216.
Yes, 216. No, you cannot use.
216.
You didn't even, I told you.
You cannot.
You did. You're like,
Because most calculators have a square root button.
No, I mean like just multiplying with the calculator.
No, I don't know what you're going to do. All right, you can't even see my paper. It says -216 times 3. 860.
isn't it
664?
48?
48? I don't know.
-648.
-648. So yeah, you need to have a huge answer for that one. Can everybody go to number 22?
Yes, ma'am.
We just did 6 to the 3rd. What was it?
16.
Okay, now, what is the square root of 36? 216 take away 6. No more square roots anymore.
210.
Okay? So this whole worksheet, 1 through 27, is just you doing different steps, different tactics. Some of your numbers will be huge, some of your numbers will not. Okay? All right.